So, I found a leak for this competition, and I thought maybe I should make a video explaining how I found it and, you know, how to use it in predictions. Hopefully, we can come to an agreement that, we can use this in the competition. I don't know. Yeah, so let's get started. The data is actually very simple. There are only three columns. In this notebook, we're only going to pay attention to the event ID and label columns. The leak is actually related to the row order. Once you load the data, you can plot the label column, and it looks like this. Immediately, it raises a big red flag. There's a leak by row order. Here, the x-axis is the row ID, and you can see that before certain rows, the label is always 0, and after that, actually, this blue rectangular area shows many vertical lines. Okay, so we need to take a step further and think about how we can clarify the leak and make the pattern more obvious. If you check the statistics of the label column, you can see that the mean value is actually very low. This is because in this competition, we have location and day information. So we can extract the location and day from the evented column. And then we can check that for each location, there are 730 days and 674 unique locations in the training data. So we can check the sum of the label for each location, and we get this data frame. However, we want to make sure to restore the original row order since Group B sort the rows by location alphabetically. And then, when we plot this label sum, we have a much clearer pattern. You can see that the first half of the locations don't have flood at all. And for the second half of locations, they have flood. And the values jump from 0 to 1. So if you check the ratio, you can see that exactly the last 47% of locations in the training data in terms of row order are locations with flood. Okay, so this is the leak pattern in the training data, and obviously this could be very useful to improve our predictions and to optimize log loss. So what we can do is, for locations without flood, we can simply set the probabilities to 0. And for locations with flood, we know that there's only one day where the label is 1, because the sum of all the days is 1 for all the locations. So that means we should normalize those probabilities by dividing the probability of each day by the sum of probabilities of the 730 days for those locations. So we need to confirm if we have the same leak pattern in the test data. We can use any of your previous submissions to check this. Simply load your submission and the test CSV, and you can draw a figure of the label sum for each location. Be careful to maintain the same row order as in the test data for the locations, and you can see a pattern like this. This is actually the opposite of the pattern in the training data, because in the training data, we have all zeros first, and then jump to 1. So this pattern shows all ones first, and then jump down to 0. Another observation is the sum of probabilities for each location is above 1, which is obviously not optimal. Okay, so I think visually we can come to the conclusion that in the training data, the last 47% of locations are locations with flood, and in the test data, the first 47% of locations are with flood. So, to confirm this hypothesis, we need to apply the leak and submit it to the leaderboard. Applying the leak is very straightforward, like I mentioned before. You can also verify this if you have a cross-validation prediction file for the training data. You can verify how much improvement you can get before and after applying the leak. So, here I have one of my cross-validation predictions. You can see that before applying the leak, it's this score. After leak, it's this score. The improvement is about 0.0003, and you can apply it to your actual submission for the test data. I did this and submitted it, so the improvement is a little smaller. Yeah. So because the test data might have a different flood location ratio than the training data, I think many people have said that they didn't use any of the leak. So my argument is it's possible that your model used it indirectly. You can actually check this visually very conveniently. Basically, you want to draw a figure of the group by sum of predicted labels for each location and maintain the location order as in the test data. And you can see the pattern like this. So for a submission without exploiting this leak, you can see a lot of noisy peak and valleys like this. You can see some pattern, but it's not obvious. If you apply the leak, the pattern will be much cleaner, and it is from 1 jump down to 0. So the closer your pattern is to this one, the more likely you have the leak in the data. Okay, thank you.